Hello, my name is Daigo. I'm the Director of Product Design for SATO. And today I'm going to talk about how we apply UCD to SATO product development. I'm going to talk about the corporate structure. I'm from the private sector, so it might be interesting for you to see some of the development work that the private sectors do to make products. How SATO got started in 2012 in Bangladesh, and then the kind of work we're doing now, which is this artifact I brought with me here. LIXIL Corporation. LIXIL Corporation is a big company consisting of all these companies, and we make housing and building products. And you might have seen some of the brands that LIXIL has under LWT portfolio. Growa at the top end, or the premium end. American Standard, where I'm from originally. But the SATO is the newest addition to the LWT brands. And what we do is we fit at the bottom of the pyramid, and we serve the basic sanitation category at the bottom. And their mission is to become the first complete brand of bathroom products for off-grid applications, bringing safe sanitation to 100 million people by 2020. So that's a big goal. Okay, so how we got started in 2012 through the grant of Bill and Melinda Gates Foundation and through the Reinvent the Toilet Challenge program. We went to Bangladesh, and with the help of IDE, we did some user research on the situation in Bangladesh. This is in 2012. We did dozens of household interviews. We did prototype focus groups. And just through observations, we try to really go deep into what the needs of people are. So we did that for a few weeks. We saw a lot of latrines, some nasty ones like this. So seeing something like this makes you want to really close that hole. Yeah? Yeah, well, at least I did. So and then we try to understand the stakeholders and everyone that touches the latrine products. So this is an example of how we study the latrine producers and how they make the latrine slabs. So we really needed to understand what they do, their behavior. Also, we needed to understand what was in the markets. So the water seals that were on the markets were predominantly these two cup traps and the P traps. But these P traps, and the people use these plastic teapot-like thing called the botnas. But the combination of the botna flushing and the 4-inch P-trap, as you can see, you need 1 liter of water to seal the 4-inch P-trap, and the botna water was only like less than a liter. There is no way you can flush this P-trap effectively with the botna. When we did the focus group, when we showed them these prototypes we made, we showed them the smaller diameter trapway to the people. So from a technical standpoint, it would work better. There's no way this 3-inch trapway would clog. Even our biggest, the Champion toilet we sell in the US, that's like 2 5/8. So the 3-inch is enormous, right? But the people's perception were, if the trapway gets smaller, it'll clog. So that was a perception. But in any case, so we try to understand what the needs are, and then we brought all this back to New Jersey, and we got to work. So this is the design spec we put for the original SATO pan. Some I highlighted. There's no change in behavior. The flush volume, it was less than 1.5 liters. So the price was going to be $1 US. We went through the ideation phase, and we decided on these 2 final models. And these are some of the things we did through the development phase. We did some CFD on the pan. We can virtually pour flush the designs. And how cool is that, right? We also made these polyurethane models in the shop. We made silicone molds. We made models. Those are some pictures of when we made the trapdoor model. And then we field tested them to see, how people liked them, how they were performing, and the trapdoor design was performing much better. So we went with that, and some people said, hey, this trapdoor design is a cool new technology. I like this. So that was more aspirational too. So we went with that, and we further refined the design. That Jim and I working in Rajai, fine tuning the design in CAD, and then we decided to go with this final design. So we partnered with the local manufacturer RFL, and in February of 2013, we had our first molded parts. So I took those T1 samples and I did testing. We always do testing on anything we put on the market. So some of the things we had to test was the temperature. So I cooked this material in this 150-degree Fahrenheit, the heat chamber, and just to see how the material would perform. And I did some dimensional checks. And also we did some flush rig testing. So we set up a rig and they dumped a liter of water inside the pan every 6 to 8 seconds. Right? So when we tested to 900,000 cycles, that would equate to about 100 years of use for the household of 5 people. So we said enough. The hinge mechanism didn't show any sign of wear, so it could have gone another 1,000,000 cycles, and I think it would have been okay. So the takeaway, to recap the first, the SATO project, the user research to production was less than 1 year. To date, there's over 1.2 million units installed, and the retail price as low as $1.50, and it's a win-win for everyone to be able to make a product that sort of like sells itself. Everyone has to win, right? Manufacturer would have to make money. The latrine producers, hardware people, they all need to make money, and at the end user should be able to afford the product. And then the recipe for success for this one was to keep it simple. My British colleagues would say keep it simple, sunshine, but just keep everything simple. Simple to understand, simple to clean, simple to use, everything simple. This is the current our latest model for India. I brought one with me. But in India, they make a lot of twin pit latrines. And everyone knows the twin pit latrines have this diverter mechanism. And a lot of the times, the way it's constructed, it clogs there. And because, again, they use the 4-inch P-trap, it requires like 5 liters of water to completely flush. So we said, all right, let's do something about that. When we got to work again, and some of the design specifications were there, but basically we wanted to make something that flushes with less water, never clogs, and make the switching easier between the pits. So the ideation phase, so we went through a lot of concepts, but the final model is something that looked like that with a bucket, the swiveling bucket inside the housing. And you can mate any pan to the unit, ceramic, stainless, plastic. And we field installed this unit in India. And those are some pictures. But as you can see, you can position the pits anywhere in relation to the pan. And it's a straight pipe run to the pit. So there's really nothing to clog. So the masons loved it. It's $2 cheaper per latrine, about $2 cheaper because it eliminates the junction box. It eliminates the P-traps, and it eliminates like half a day to 1 day of labor because it makes the whole construction process easier. So they loved it. So we made this V-trap from concept to production in about 10 months. And the initial talks with the government people in India, we're expecting a sale of millions per year. So right now we're making molds, many molds to build capacity. Lessons learned from all these SATO projects. The importance of being on the ground, UCD, we need help on the ground because let's face it, we're private sector. We don't have any presence in these markets. So we need partners like, the Gates Foundation, UNICEF, IDE, WaterAid to show us around and see what the problems are. And, you can't smell a latrine from my desk, so I really got to go there and really understand what people are going through. And the design process, I just showed you, we go through many steps. And usually the first solutions that comes to your head isn't the best solution. So you have to take it through the process, try different things, fail many times, and then get to that one that might work. But then you still got to field test that, make improvements, and then get to the final product. But while you do this, the input you got from the user, if the users told you, hey, I can afford $1 for a good latrine pan or $1.50, you keep to that. Not $2, not $3. Keep that price range. And that goes to scale up. I'm asked a lot, like, to scale up what the most important thing to do is. But I think for scaling up, to keep everything affordable and to build a value proposition for the money you're asking, that's the best way to do it. Because let's face it, we all want expensive and nice things, but if we can't afford it, we can't buy it, right? So I think that's the same kind of thinking we have to put to the sanitation products too. The last thing is the attention to details, and I wrote material use, but the last step of my design process is to take even a gram out from each component. So if you think about it, you say it's just a gram, but over the life of a mold, and let's say you take 1 million shots, that's 1 million grams of material you can save and give that saving back to the user. That's 1,000 kilos of material. So, things that drive cost, you try to look at that before you commit to molding or, making a mold, and get that up front so you can get savings to the user. Thank you.